Our STS project for Physics 20 is focused on the sport of snowboarding. We will touch on topics of momentum and energy, kinematics, and dynamics. There is a lot of physics within the sport of snowboarding, and we will show you how we were able to find things such as acceleration, velocity, and potential energy. In order to retrieve this data, I took a GPS with me to the slopes and recorded data.
Kinematics. Let's start with a simple topic from kinematics, acceleration. As you are riding down a hill, your acceleration will speed up. Your acceleration is going to change due to the steepness of the hill. At the end of the run, when you start to slow down, this is going to be negative acceleration. Our estimated acceleration for Dan's run was 0.826 meters per second squared. The theoretical acceleration for Dan's run was 0.639 meters per second squared.
Our next focus is going to be on velocity. Velocity is the basis of snowboarding. It is what allows you to get down the hill. Also, your velocity is what adds danger to the sport. If you happen to run into something or someone at a high velocity, then you risk injury. Dan's recorded value of velocity was 25.1 meters per second. By using this and the formula T equals D over V, we were able to figure out the actual and theoretical time it took for him to go down the hill. Dan's actual calculation was 15.2 seconds, and the theoretical calculation was 17.3 seconds.
These are our actual and theoretical values. We calculated our theoretical speed and our actual speed. We were then able to figure out our actual and theoretical acceleration. My GPS had some percent error due to the mountain giving my GPS false readings.
Jumps. In snowboarding, you have the option of going off jumps. These jumps can range from many different inclinations. Our chart shows the different velocities, vertical and horizontal distances, and seconds in the air in relation to the angle of the jump.
Momentum and energy are directly related when referring to snowboarding. The potential energy that you have at the top of the hill gets converted into kinetic energy as you are going down the hill. By using the formula EP equals EK, we are able to calculate my velocity as I went down the hill. My theoretical velocity, or what I should have been going, was 22.1 meters per second.
Dynamics. Gravity affects all snowboarders. Because of gravity, you are pulled down the mountain and your board is kept on the trail. If you did a jump and there was no gravity, you would never come back to Earth and you would just stay up there forever.
Friction is especially important on the half pipe. If there was no friction for the half pipe, you wouldn't be able to stay on the surface and you would always reach the exact same height as the previous path. If you don't have a very fast speed, you won't be able to get any air off the edge. As you go vertically on the half pipe, your acceleration will decrease negatively due to gravity. The acceleration increases as you land and go across the opposite side of the pipe. Half pipes are angled downward, so you can keep a constant speed as you lose energy to friction.
There are many different scientific aspects that correlate with the sport of snowboarding. The whole sport has to do with physics. We can calculate the acceleration of the boarder, how long it will take for the boarder to travel down the mountain, and also the maximum velocity. The potential and kinetic energy were able to equal each other once we calculated them.
Ecological. There aren't many ecological issues that are caused by snowboarding. It may harm the ecosystems that live on the mountains, and the chemicals of the wax may harm the earth. They are composed of plastic, wood, fiberglass, and in some cases carbon fiber. In the making of snowboards, the earth may become slightly more polluted due to the contents of the snowboard. The bindings are made of plastic and metal, which can also harm the earth when they are made.
In the different board styles, they can make a snowboarder travel faster or make them jump better. Freestyle boards are more maneuverable. The racing boards are longer and are made lighter and thinner, which results in less friction so the boarder can travel faster down the hill. Freestyle boards are made to increase the friction, which is very beneficial to beginners, as you would want less speed when first learning. Some boards are wider and made for more power, so they have more surface area to stay on top of the powder. Some boards are made thinner to travel on groomed runs and terrain parks.
Social. The ski hill can be an environment for all ages. You can take your family there and spend the day skiing and eating at the restaurants. You can go with your friends and make it a week-long trip. They have ski lessons for beginners and for experts alike. In Canada, because of the long winters, it is a favorite pastime of many people.